Okay, hands-on session number 3 about stroke. I want to show you an example. Here we imported the connectome and the cortical surface of a patient with a stroke. As you can see here, as we scroll through the cortical surface, you have these nodes in there and the white edges, and a lesion, as you can clearly see in the cortical surface, which is at the temporal, occipital, or parts of parietal cortex. And now, this is not provided as the default data set with TVB, but what we will try to do is we will use the John Doe's connectome and try to approximate the lesion which would happen in this area. So if you take a closer look, like this, you can see there's mainly like 3 regions affected here. And we will now manipulate the default connectome and cut out those 3 regions by manipulating the connectivity matrix and use this as a new connectome to simulate. So I just switch back the tabs. Yeah, here we go. So is everyone, so if you want to follow me now, you should then switch to the connectivity page, pressing connectivity in the right lower corner, and choose the default connectome of John Doe. Now, to manipulate this connectome, we would have to switch, or we will manipulate this matrix on what you can see on the right side. But since the lesion was on the right hemisphere, we will have to switch the quadrant by clicking on Q1 or Q1 and select quadrant 4. So the difference is, you will see, so these are all L, V1, L, V2, and so on. So these are all the intra-hemispheric connections in the left hemisphere. And if we can switch to quadrant 3 just to look. These are the interhemispheric connections between right and left hemisphere. And what I want to show is quadrant 4 is the intrahemispheric connections in the right hemisphere. So if we, let me increase the transparency or decrease transparency of the surface. Yeah. So we were somewhere here in the right parietal cortex or temporal cortex, and actually it was 3 regions which were affected. One is the right parietal cortex inferior, RPCI, which if you click on this node, where's my mouse? Here it is. If you click on this node, the name will appear in the right upper corner. So this is one. Then I would say S1, somatosensory cortex, was affected too, up here, and then something like the right temporal cortex, C for central, I think, was affected too. So we will now select those 3 regions in the connectivity matrix and delete all in and outgoing edges. How do we do this? Well, we can press any entry in the row of your choice. So let's start with RPCI. Press any entry in this row of RPCI, left mouse click, and then say, you see RPCI, cut in and cut out. What you also should see is that these edges on your right, on your left representation of the connectome should disappear. If you click hide, and let me select the other 2, so RTCC and S1. Okay, so these are the remaining edges we want to cut out. I will decrease transparency again. Okay, here you can see. So for our PCI, we already cut everything, or we set everything to 0. Now these 2 are remaining. So for our S1, also click the first entry in the connectivity matrix and click cut in and out. And you see how this whole row and this column is set to 0, and also the edges in our three-dimensional connectome disappear. And now the same thing for our TCC. Cut in and cut out. So one thing you all also maybe noticed is that these two regions are now colored in black, not in green, the nodes, which means we have deselected them, and if we save this connectome as is, we will have two regions less than before. So they are completely now deleted from the connectome. If you just want to set all the weights to 0, but still simulate this region, just click on the name again, and they're selected again in the connectome. Could everyone follow?
Can you show how you get to the viewer, to get the viewer to look like this again?
What do you mean exactly? The edges?
Yeah, and then the cortex. Sure. How do you get the cortex?
Oh yeah, press on this brain button, and there's brain surface, and select, and then press update visualizer. This should do the job. Press right upper corner on this brain, or this TVB symbol. What do you mean? Yeah. Press on the first entry here. If you want to exclude one area, press any entry for this row you want to exclude. And then cut in and out. So cut in will set all incoming edges to 0. Cut out will set all outgoing edges to 0 as well. I just want to make sure that you understand that if I deselect this region, so right now all regions in this connectome are selected and will get saved in the new connectome. But if I do something like this, these regions are deselected, and then if I save the connectome as it is now, it will have only 72 nodes instead of 76 as before. Yeah? But we cut these edges, but we want the connectome remain, or we want these regions remaining in the connectome.
Was everyone able to cut the edges, or did everyone not cut the edges? One more. I cut it wrong. No.
What?
Revert to the default.
You cut the wrong node?
Yeah.
Refresh the page, reload the connectivity, because all nodes are set to 0 now. So if you have done so, you can enter a name up here in this field, large scale matrix. Enter a name, call it stroke, and then press this star button over here. And what you will see then up here is launched connectivity creator in the right upper corner. Just will disappear in a second as well. But what happened now is you created a new connectivity, and this will be saved in your project under the name stroke. Okay, so has everyone saved this new connectivity? Then, where's my mouse? There it is. Yeah, go back to the simulator page. And from this drop-down menu, you should actually see a new connectome. Right. 509. But today is not the 25th of January, it's the 26th. There it is. Yeah. So the one with the date of today. So it is saved under the subject John Doe. with the timestamp of today and the time you just created it, and with a certain identifier. Now what we can do is we can actually just click. You should probably still have this parameter space exploration from the first hands-on session, where we use the normal default connectivity. Just copy this, press the pencil in the history bar, and press copy. So in the first hands-on session, we did the parameter space exploration across 2 dimensions, and now we just copy all the settings, and we will run the same thing with the stroke connectome. So if you've done this, then you will see something. So I called it something REST Explore, and now it's called copy of REST Explore. From the drop-down menu now, long-range connectivity, select the connectome you just modified with the timestamp of today and now time. Should be the first simulation where you had the parameters, basically 2 ranges, A and A. Yeah, that's the one. So if you now select the new connectome from this drop-down menu, you can leave all the other settings as is, and then I'll reduce commutation time. And then hit the play button, or actually name this something else. I will name it Stroke Explore, and then start the simulation. Yep. The start button, and then
I already delete those.
yeah, cool.
I delete those.
Yeah, perfect.
So I just click the start button.
Yeah, and
What is this button?
branching again for taking this into another
So I click this.
launch connectivity creator. Now
So-
you
so
can go
it's-
back to
So then
you will see it in your project data.
so I'll be able to see it here, right?
Yeah. So with the timestamp of today, actually 26, you already created several.
But
So the latest one.
The timestamp is the.
Sometimes it takes some refresh page or create a new simulation there.
Okay.
Well? And now it's there. Yeah. So are the simulations running? My already is finished. No, it appears under John Doe, under the subject. No. No, just copy all the settings from the very first simulation before stimulation. Very first, copy this and insert a new connectome, and then run the simulation again. So how far are simulations? Are they finished? Or still a work in progress? Then you probably didn't explore across different parameters. Did you click expand range here? Yeah, then you will only have one simulation. Click on, you will see on the right corner there's some button called results on the right side. Click on it, and then there is something called time series region. Then click on visualizer tab, and there should be a 3D and 2D activity viewer. And now with the new connectome, you mean? Yeah, because this one is not equipped to, so it's a new connectome created. It's not equipped to any cortical surface or the region mapping, you know. So one could probably adjust this too in the project data file. But right now, TVB doesn't know on what surface to project the time series. That's the reason. But you can explore time series with this. Do you have? So I think at this view it's not possible. Normally it's always with the right upper, with this TVB symbol in the right upper corner. Yeah. So let's have a look. Yeah. So this is the time series viewer. Just plain time series, and now let's select the regions we and some others. Yeah. Yeah. Okay. So did the simulation finish for everyone? Okay. Then click any point, any parameter combination you want to look at the time series at. So I go back. You have all these points here, and select any one, any exploration you find interesting. So I just go into the right upper corner here. Click on this, and this menu will open. And from here, choose the visualizers. And then select time series viewer or time series visualizer.
Is it your option to see the all-to-all functional connectivity of this old time series?
Right, that's the next step. We will compute functional connectivity on this simulation. From this button, select input signals in the right upper corner. Now deselect all by clicking on this empty box. So now we didn't select any regions, and TVB will just project all time series on the screen. Let's select the regions we have deleted all the in and outgoing edges for. So this would be RPCI, RS1, where is it? There, and RTCC. And as you can see, this is the dynamics we from the local model we put in our simulation, these oscillations, and then in the end the flat line. But now you can also select some of the others regions which still show this ongoing oscillation. Now this was the effect of the stroke in our study. Now let's compute the functional connectivity of this time series. So we will go back to the simulator page, clicking this return. Or am I too fast? Did everyone arrive at the time series visualizer? No? Then please raise your hands if you, or ask. Do you? Yeah?
I don't have the RPCI.
In your connectome? In the whole connectome, or just in this visualizer?
thought it was normal because in the store.
Yeah. Probably you have removed the whole region. Did you select? So you probably end up with only 74 regions now, or 73. 73. Yeah, you deleted the whole area from the connectome, so it's not there anymore in your simulation. In my case, I just cut out the edges, but the area is still there. So it will get computed, but has no communication to the rest of the network. In your case, it doesn't get computed anymore.
But if it got computed, shouldn't it then be possible to also project on the surfaces and make them colorful?
Yeah, this is just a thing about TVB and its connection to the specific data type. So by hand, you can then select which cortical surface should it be projected on. You can link them. Good. So go back to the simulator page to see your parameter space exploration. And now we will make use of one of the analyzers in TVB. We will select one simulation of your choice. I'll go again with this one up here. Click on it. And then choose the Analyzers tab. And here are some of the before mentioned options to analyze your simulation within TVB. And we will select Pearson correlation coefficients down here. And if you click on this, on Analyzers, you're on the simulator page, and then click on one of these colorful circles. And then go to the Analyzers page, and we have here Pearson correlation, yep. And if you click this, nothing much will happen. Something will happen. It actually will compute the functional connectivity, but you have to look into the right upper corner. It's gray and gray. It says operation launched, and it just takes half a second or so to calculate this. So close this menu, and then go to project. Click on project down here, and go to operations. And the latest operation which is finished should be called Pearson correlation coefficients. And on the right side, on the results, or the results column, you can see this file CC. And click on this. Did everyone arrive here? So after you pressed Pearson correlation coefficient, switch to or click on project and choose operations. And you should see the latest operation should be called Pearson correlation coefficients. And on the right side, under the column results, click on CC. Yeah.
Can I ask a question related to a few steps back? So why couldn't we this time display the 3D view? There was only the option of the types.
Yeah, this is because the new connectome we created is saved in a different file and is not equipped with the cortical surface from the subject before. You can link this probably. It's possible to link this somewhere in the user interface as well, right? Yeah. But there's for simulation result, there was no specific button for the 3D visualization then. Yeah, let's answer it later. And then go to press on CC, choose the visualizers, and press Pearson correlation coefficients. And this is what you should see. So the functional connectivity of our simulation.
So the neighboring region are all highly correlated.
Right. Most of the regions in our connectome are very highly correlated, very synchronous. There's some exceptions, though, and those are, if you remember the connectivity matrix of our connectome, it was the first 38 regions was left hemisphere, and the last 38 regions was right hemisphere. And so we here just have the numbers. Oh no, we have actually yeah. So you actually have a name here. And if you go into this functional connectivity, on the left upper side, you can see the entry for the correlation coefficient for this entry, and you can see between which regions this is computed. And here it's the right temporal cortex central, which is the one of the regions we cut out. You probably choose the different visualizer. So if you click on CC again, and there are 4 options. Some just show the complete matrix, some show the half of it. But because the matrix is symmetric, there shouldn't be a difference.
So what correlation are we looking at? Sorry.
The correlation coefficient between the time series, between the regions. So each entry is the correlation coefficient of a region pair. Yep. Yes?
So far we have only looked at one model, and we compare all the models with different parameters of the same model, the matrix that we have chosen.
If you want, yes, you can use a different model to compute the functional connectivity, or what is it?
Can we compare?
In what way? I mean.
So now we try different parameters for A, B, and now we choose one. But could we compare the different parameter connectivity matrix?
You mean something like this 2-dimensional parameter space exploration? One dimension being one model and the other being another local model. Is that your question? Yeah, but that's not implemented within the virtual brain yet, no.
So if we want to compare the functional connectivity of the models, then we need to export the data and compare them in different software.
I mean, you can just go back to the simulator page, run simulations with another model, and also compute the functional connectivity like this for another model. If that answers the question.
The same model but different parameters.
Yeah, that's possible.
And as you said, you export the data and do your analysis with them.
So for other like FaceTime series-based functional connectivity, you have to export time series, do it yourself.
Yeah. So as Randy said, TVB is more simulation platform. It provides some analysis functions, but it's rather meant for simulation, and then export the time series and do the analysis on with your own preferred system.
Is there a way to get those time series power spectrum in the TVB?
Yes. Go to analysis in the lower button, the lower panel, and there is spectral analysis here. And then from the drop-down menu, choose one of the simulations. Or you go back to the simulator. So here it's kind of it's not so clear. Maybe go back to the simulator page, and again then choose there the simulation you want to analyze, and go use FFT over there. So you click in the PSE, choose analyzers, and then there's FFT over here as well. Good. If there are no more questions, that was it on the hands-on session on stroke. Yes?
Sorry? So code to see what these things do. But if you mean something like Blender does, have a help button somewhere that directly links to the source code, that's not there.
And is it possible to record commands?
No. If you want to do that, you will have to use the scripting.
So later on, in a later session, we will also see the script interface, which is also available, and there you can batch the scripts and do everything you like. So we will have that in the next session. Now we have a coffee break. It will go until 4:45. And I would like to ask the speakers and the TVB staff to collect on the terrace for a moment. Jessica wants to take a photo.